All right, next we're going to talk about graphing systems of inequalities. So the first part is all the same, graphing the lines, but with inequalities, we're not necessarily looking for points of intersection. We're looking for where the shading overlaps. So we're looking for a large set of points instead of just a specific point. So first thing we have to do is get y by itself though. So to get y by itself for this first equation, we're going to subtract 4x to the other side so that we get 3y is greater than negative 6 minus 4x. And then final step, we'll divide everything by 3. So we get y is greater than negative 6 divided by 3 is negative 2. Negative 4 divided by 3 does not reduce, so we leave it as negative 4/3 x. So we'll plot our y-intercept at negative 2, and then with a slope of negative 4/3, we can move down 4 and right 3, or up 4 and left 3. All right, since these are inequalities, we do have to pay attention to the kind of line we draw. So since this is just a greater than symbol, not a greater than or equal to, this will be a dashed line all the way through. And with greater than, we want to shade where y is increasing, and y increases as we move up the y-axis. So we're going to shade everywhere above our line. Let me give a little better shading. So we're going to shade everywhere above that line. All of those points are solutions to that first inequality. All right, for our next line, we're going to subtract x to the other side again. So that's going to give us negative 3y is less than or equal to negative 9 minus x. And then final step, we'll divide everything by negative 3. Now with inequalities, we have to remember to flip our inequality when we divide by a negative number. So instead of less than or equal to, now we're going to have greater than or equal to. Negative 9 divided by negative 3 is a positive 3, and negative 1 divided by negative 3 is a positive 1/3 x. So we'll plot our y-intercept at 3, and then we'll move up 1, right 3, or down 1, left 3. Now for our line, this time we do have an equal to bar, so that means we can just draw a regular solid line like we're used to drawing. And now for the shading, we have another greater than symbol, so that means we're going to shade up the y-axis, which is above our line again. Now, like I said earlier, we're not looking for that point where they intersect, we're looking for where their shading overlaps. And their shading overlaps where we see the blue and red come together. It might be helpful if you use two different colors, just so you can see where those colors are overlapping each other. Pencil can get confusing. So then we'll shade that area where the shading overlaps the darkest, and that's our answer here. We don't have an ordered pair as an answer, we have a shaded region. So make sure you're shading that part in the darkest. All right, next one. Another set of inequalities, but this time we have a parabola and a line. So for our parabola, we've got y is greater than or equal to x squared. You can use your calculator to help you find some points if you want. This is just the parent function of our parabola. So that means we have a point at 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. So it's just centered at the origin and then goes up from there. Now looking at the inequality they gave us, it was a greater than or equal to inequality, so that's how I knew I could draw a solid parabola and not make that a dashed parabola. And then for shading, it's a greater than symbol, so we want to shade up the y-axis, and up the y-axis is going to be inside our parabola. So we're going to shade everywhere inside that parabola. And then next for our line, we've got y is less than or equal to x plus 3. So we'll start by plotting our point at positive 3 on the y-axis. And then we have a slope of positive 1, so we'll move up 1, right 1, up 1, right 1, or down 1, left 1. We have an equal to bar again, so that means we can draw a solid line through those points. Off the edge there at the end. All right, and then shading. We want to shade where y is less than our line this time. So that's going to be moving down the y-axis. So that's going to be everywhere underneath our line. So we'll shade all of this in. And then again, our answer is where that shading overlaps. Make that a little smaller. Our shading overlaps in this small section at the bottom of our parabola. So just make sure you get that colored in the darkest. So I can see where that shading overlaps, so you can see all the set of points that are going to be solutions to both of these inequalities. All right, final one. We've got two parabolas again. I went ahead and set these up ahead of time. Again, you can use your calculator to help you find some of these points and get those plotted. Our focus right now is not necessarily graphing, but the shading and finding that solution. So that's why I got these set up for us ahead of time. So now all we need to do is go back and figure out where we're going to shade. So for the first parabola, which is in blue, we have a greater than symbol. And with greater than, we know we want to shade up the y-axis, which is going to be inside our parabola because our parabola is opening up. So we'll shade everywhere inside that y-axis, or inside the parabola. And then for our second parabola, which is graphed in red, we have a less than symbol. Notice that neither one of these have equal to bars, so that's why they are both dashed parabolas and not a solid curve. So for our second parabola, we have a less than symbol, which means we're going to shade down the y-axis, which again happens to be inside the parabola because our parabola opens downward. So we'll shade all inside there. Now if you notice, none of the shading overlaps. And if none of the shading overlaps, that means they have no points in common, which means there is no solution. So this is going to be the only time that we actually have an answer that's not represented on our graph. When the shading does not overlap, you need to write out no solution as your answer. Otherwise, just color the shading in darkest where it does overlap. So that is how we graph and shade systems of equations that are not just lines. So we're not necessarily always looking for one solution. Sometimes we're looking for multiple solutions, or we're looking for where our shading overlaps.